back to another video, and today we're going to be doing lesson 3 and 4, limits and infinity and negligibility. I combined two lessons into one because they are sort of the same concept. We'll first talk about limits and infinity, and then dive into the easier ways of evaluating them and how the idea that contributes to your understanding of this. So, firstly we're going to do the overall concept of a limit at infinity. So if we have the limit as x goes to negative infinity of 3x plus 5 over 6x minus 8, what happens when you plug in infinity? You plug in infinity, you're going to get 3 negative infinity, we're going to get 3 times negative infinity plus 5 over 6 times negative infinity minus 8. Now if you think about it, do these values here even matter? Because if this is going to go to negative infinity, and this is going to go to negative infinity, then these are, well, we'll get into it later as negligible. But for now, just think of this concept. If this goes to infinity and this goes to infinity, these don't really matter. But what does matter are the coefficients to the infinities. Now we know these negatives right here are going to cancel out. So, in the end, you're going to be left with 3/6, which this becomes 1/2, which is a basic idea of limits at infinity. However, as we move to the more complex constructs of this idea, we're going to solve this algebraically. So how are we going to do this? Let's take the same exact limit, as x goes to negative infinity of 3x plus 5 over 6x minus 8. But this time, we're going to use this rule called dividing by the highest power on the bottom. So on the bottom, what is the highest power? X to the first. So, this is called the algebraic solving of an infinite limit. So what we're going to do is we're going to take the same limit at negative infinity, and we're going to divide by an x on the top and the bottom, and that's going to let us evaluate our limit. So what we're going to have is this, the same thing, 3x plus 5. But this time, it's going to be over an x. And then we're going to take the same thing on the bottom and divide it by an x. So that gives us, if we bring this down again, this is going to equal 3 divided by x is just 3. This is going to be the limit as x approaches negative infinity of 3x divided by x. If we split this up into a 3x over x plus a 5 over x all over 6x over x minus 8 over x. This is going to cross out, that should be an x here, and we're going to be left with lim x goes to negative infinity of 3 plus 5 over x all over 6 minus 8 over x. Now, a basic thing you need to know about limits to infinity, if the bottom of something like this if this x equals a negative, whether it be negative infinity or positive infinity, if the bottom is going to get increasingly bigger, this fraction, the value of this fraction here is going to decrease. Because if you divide something by, 1 million, it's going to be, this right here is going to be less than, let's say, 8 over 1, right? This is going to be 8. This is going to be some huge fraction. So when we're solving these limits, we can think to ourselves that anything divided by infinity is going to be 0. So therefore, this whole thing goes to 0. This whole thing goes to 0 from the left, because this is negative infinity. So what happens is both of these become 0. It doesn't even matter what sign they are, whether they're negative or positive. It doesn't matter, because these are becoming so small, infinitesimally small, that they're basically 0. So what are we left with? We're left with 3/6. So our same limit as x goes to negative infinity is now solved algebraically, and we're left with 3 over 6, which equals 1/2, and that is our answer. So that's how you evaluate in the limit. And we already used some constructs of what we're going to get into next, negligibility, because we crossed out these zeros as negligible. So our next little subtopic here is negligibility. And this is going to get into the rigorous limits, which is 1.4 of the AP Calculus curriculum. So we're going to start out with a different limit this time. And this limit is going to be very complex. So it's going to be limit as x goes to positive infinity of the cubic root of 3x plus 5, all divided by, just the inner function divided by 6x minus 8, all in parentheses. So, if you noted our limit properties from the previous sections, we know that we can pull this cubic root out and just take it at the very end once we solved our inner limit, which is going to give us basically the same function we had before. So this can be pulled out, and we're going to get the cubic root, the cubic root of this limit as x goes to positive infinity of 3x plus 5 over 6x minus 8. And now instead of dividing by the highest power on the bottom, here instead of dividing by x like we did before, what we're going to do is this, negligibility. This is more of a construct in your mind. So you have to think, if we're going to go to plug in positive infinity for x, this 3x, like I said before, is going to go to infinity, a positive infinity. This 6x is going to go to positive infinity. So if these are basically equal to infinity, 8 is incomparable with infinity, so therefore those values are negligible. They have zero, an infinitesimally small effect on the actual value of this limit. So we can cross this out and show our work is this. Cross through like usual, arrow, and then put neg for negligible. -8, negligible. Are these x's negligible? No, because those are variables. And we're plugging in infinity, so the x is actually the most important factor. However, these coefficients, 3's and 6, are not negligible. They're not negligible. Why? This is because since both these values are basically the same, what we're trying to find is the ratio of infinity to infinity. So we have to find this ratio, which is 3 over 6, and that's going to give us 1/2 like normal. So you have to think about the coefficients to your infinity, because if these are equal, if we plugged in, let's say instead of infinity, this was x approaching 1, and we plug this in, it's still going to be a half. Or if it was x equals 2, still going to be half. X equals 5, still going to be half, because these values are the same. and therefore we're just looking for this inner ratio. And since the inner ratio, since these values are negligible, we don't count them in our infinitus ratio, right? So let's start with another example, something a little bit different. So we're working with different digits. Let's do something like the limit as x goes to negative infinity this time of square root x squared plus 2 all over this time 3x minus 6. Okay, so since the square root is not on the whole argument here, we cannot pull it out, so we're going to have to solve it the way it is. So this is going to equal the limit x goes to negative infinity of, alright, now let's think. Before we plug in any values, what's going to be negligible as we go to negative infinity? As we go to negative infinity forever, what doesn't matter in the long run? Well, that's going to be 2 and negative 6. Those don't matter. So we're left with this. The limit is x goes to negative infinity of root x squared over 3x. Now, many people are going to make the mistake of this. They're going to say, oh, look at this. Perfect. We're going to have this limit. And then square root of x squared, that's x over 3x. Cancels 1/3. Not necessarily. It does happen to be the right answer in this case. However, when you're taking the limit of something, if you've learned in your previous units, the limit of the square root of x squared is not just x. Square root of x squared is the absolute value of x. Okay? But how do we know? We know that this limit is a piecewise function that's going to look something like this, right? It's going to be like this with a hole at 0, and it's going to continue at the top. So, if this value of x equals negative, if it's negative, it's going to be down here. So we're actually going to put the negative in front of the absolute value. So if the absolute value of x, and x, let's see, equals negative 5, it's not just going to equal 5 this time, because according to our piecewise function, we're going to have to put a negative in front of this when we evaluate square root of x squared. Same if it was positive. If this was a positive 5 right here, we're going to put a positive coefficient in front of this absolute value. So you have to remember that when you're taking the limits of a complex limit like this, of a complex function like this. So we know that x is negative in this case. X is a negative value. So, sorry, the positive 1/3 was not right in this case. So since our x value is a negative infinity, it's not just going to be x over 3x. It's going to be the absolute value of x, but we're going to put a negative coefficient because it's negative infinity. Okay? And then this is going to stay the same, and it's going to be 3x on the bottom. So if we plug in infinity, we can't just cancel these out nonchalantly. We have to take the absolute value of x now. So what's the absolute value of negative infinity? Infinity, but according to our piecewise function that's like this, it's going to be still negative infinity because we evaluated the piecewise function and we know we have to put a negative coefficient. So this on the top, even though it cancels out and it's this limit without the infinity equals positive infinity, in the end it's going to equal still negative infinity to keep the rule of our piecewise function. And this on the bottom is going to be 3 times a negative infinity, but these values cancel out, right? And we're left with 1/3 as our answer. And we know this because we had two negative values, so the negatives are going to cancel out, and we looked at our piecewise to know that the square root of x squared is not always x. It's actually the absolute value of x. But if x is less than 1, if x is less than 0, this becomes negative absolute value of x. And if it's greater than 0, positive. If it equals 0, well, there's a discontinuity there. There are two holes. But anyways, thank you guys for watching. That is all I'm going to be covering today for limits to infinity. Negligibility, I tell you a neat trick you can use on your exams. Just put a dash through when it's negligible, just like this up here, and you'll be good to go. So, thank you guys for watching. Make sure to like, subscribe, and follow for more. Thank you.